This simplified diagram illustrates the principle of operation. When a blade is in position in the air gap, the Hall generator and the IC are shielded from the magnetic field. The signal voltage is not switched and transistor T0 is off. The base of transistor T1 is positive, and a small current flow through the base emitter allows a heavier current to flow through the collector emitter. This heavier current then flows through the base emitter of T2, and T2 is switched on. Current can now flow through the ignition coil primary winding and through the collector emitter of T2 to ground. This completes the primary circuit and establishes the magnetic field in the ignition coil. With distributor rotation, the blade exits from the air gap and a window enters. The magnetic field at the Hall assembly now permeates the Hall generator and its integrated circuit, and the signal voltage turns on the base emitter of T0. The circuit, now established through the collector emitter of T0, diverts current away from the base circuit of T1, and T1 switches off. Since T2 cannot function without the action of T1, T2 also switches off. This breaks the primary circuit, generating a self-induced voltage in the primary winding, a mutually induced voltage in the secondary winding, and creating a spark at the spark plug. Maximum primary current flow and dwell angle are controlled by the ignition module. With continuous rotation, the primary circuit is established and interrupted as each blade enters and leaves, providing a spark for each cylinder in turn. Ignition advance according to engine speed and load is provided by centrifugal and vacuum advance mechanisms. Engines with engine management systems don't use centrifugal and vacuum advance mechanisms. Precise control of ignition advance according to engine load and engine speed is provided by the Engine Management Electronic Control Unit, or ECU.